Here is the trap almost every developer falls into when they start grinding LeetCode. You open the problem list, you see 2,000-3,000 problems, and you start at the top and grind. 50 problems in, a new one shows up and it still feels brand new. You are memorizing answers instead of learning to solve. Here is the shortcut nobody tells you. The famous blind 75, the curated list most people use to prep, is not 75 unrelated puzzles. It is really about 12 reusable patterns wearing 75 different costumes. Learn the 12 patterns, and you can recognize almost any problem on site. In the next few minutes I will give you all 12, what each one is, the telltale signal that screams use me, and the exact example problems where it shows up. So why do patterns beat brute force grinding? Because interviews do not test whether you have seen a specific problem. They test whether you can map a new problem to a technique you already know. Think about how a strong engineer reads a problem. They are not searching their memory for that exact question. They are scanning for signals. Is the array sorted? Is it asking for the longest substring? Are there dependencies between tasks? Each signal points to a small family of solutions. That is the whole game. A problem is just a signal wrapped in a story. Grinding 500 problems trains your memory. Learning 12 patterns trains your recognition, and recognition is what actually transfers to the problem you have never seen before. So we are going to group the 12 patterns the way they naturally cluster, arrays and strings first, then linked lists, then intervals and search, then graphs, then dynamic programming, and finally heaps and tries. Let us go. Start with arrays and strings, because that is where most problems live, and 3 patterns cover almost all of them. Pattern 1, 2 pointers. The signal, the array is sorted, or you are looking for a pair, or checking a palindrome. You place 1 pointer at each end and converge toward the middle. That turns a nested loop into a single pass. You see this in 2 sum 2 on a sorted input, in valid palindrome, and in container with most water. Pattern 2, sliding window. The signal is a contiguous subarray or substring with a constraint, the longest, the shortest, the maximum something. You grow a window from the right and shrink it from the left as the constraint breaks. Longest substring without repeating characters is the classic. Minimum window substring is the hard version. And maximum subarray is the running sum cousin you solve with Cadon's algorithm. Pattern 3, hash map or set. The signal, you need constant time lookups, have I seen this before, how many times, which things group together. 2 sum in 1 pass, contains duplicate, and group anagrams all fall out of a single hash map. When brute force is order n squared because of repeated lookups, a hash map is almost always the fix. Now linked lists, which have one signature trick you must know. Pattern 4, fast and slow pointers, sometimes called the tortoise and the hare. You move 1 pointer 1 step at a time and another 2 steps at a time. The signal, anything about cycles, or finding the middle of a linked list in 1 pass. Here is the intuition. If there is a cycle, the fast pointer eventually laps the slow one and they collide. That is how you detect a loop without any extra memory. And if there is no cycle, when the fast pointer reaches the end, the slow pointer is sitting exactly in the middle. Linked list cycle and find the middle of a linked list are the 2 problems that teach this. Once you have seen it, you spot it instantly. Next, 2 patterns that both lean on sorting or a sorted structure, intervals and binary search. Pattern 5, merge intervals. The signal is obvious once you know it, the input is a list of intervals, ranges with a start and an end, and you need to combine or compare overlaps. The move is almost always the same, sort by start time, then walk through and merge any interval that overlaps the previous one. Merge intervals, insert interval, and non-overlapping intervals are the 3 to drill. Pattern 6, binary search. Everyone knows it for a sorted array, but the real signal is broader, any monotonic search space, or a problem that says minimize the maximum, or maximize the minimum. If you can ask a yes or no question that flips exactly once as you increase a value, you can binary search the answer. Search in rotated sorted array and find minimum in rotated sorted array are the array versions. Coco eating bananas is the mind bender, you binary search over the eating speed, not over an array at all. Now graphs, where 3 patterns handle almost everything. Pattern 7, breadth first search, or BFS. The signal, shortest path in an unweighted graph, or anything level by level. You use a queue and expand outward one ring at a time, so the first time you reach a node, you reached it by the shortest path. Number of islands, binary tree level order traversal, and rotting oranges are the 3 canonical BFS problems. Pattern 8, depth first search and backtracking. The signal, explore all paths, generate every subset, every permutation, every combination. You go deep, and when a path fails or completes, you back up and try the next choice. That undo step is what backtracking means. Subsets, permutations, combination sum, and word search all come from this one template. Pattern 9, topological sort. The signal is dependencies, do this before that, prerequisites, ordering tasks in a directed graph with no cycles, ADAG. You repeatedly take whatever has nothing left blocking it. Course schedule 1 asks can you finish, course schedule 2 asks for the actual order. Both are topological sort in disguise. Now the pattern everyone fears, dynamic programming, pattern 10. It is not magic, and the signal is very specific. You reach for DP when a problem has 2 properties. First, overlapping subproblems. You would solve the same smaller problem again and again in naive recursion. Second, optimal substructure, the best answer is built from the best answers to those smaller pieces. In practice, the signal shows up in the wording, number of ways to do something, or the minimum or maximum cost or length. Climbing stairs is the gateway, the number of ways to reach step n is the ways to reach n-1 plus n-2. House robber is a choice at each step. Take this one and skip the neighbor, or skip it. Coin change is minimum coins to make an amount. And longest common subsequence is the 2-dimensional version over 2 strings. Same idea every time, define the subproblem, then build up from the base case. 2 more specialized patterns that each own a very specific signal. Pattern 11, heap or top K. The moment you read K largest, K smallest, or K most frequent, or you are processing a stream and cannot sort everything, think heap. A heap keeps the best K elements for you in order log K time, so you never sort the whole input. Top K frequent elements, kth largest element in an array, and merge K sorted lists are the 3 that lock this in. Pattern 12, tree, or prefix tree. The signal is prefix matching or a dictionary of words, autocomplete, spell check, does any word start with these letters? A tree stores words character by character down a tree, so shared prefixes share a path and lookups are proportional to the length of the word, not the size of the dictionary. Implement tree is the one you build from scratch. Word search 2 is where a tree turns an impossible brute force into something that actually runs. So now you have all 12. But here is the skill that actually matters, recognition. The patterns are useless if you cannot map a new problem to the right one under pressure. So train the reverse lookup. Do not memorize solutions, memorize signals. Sorted array or a pair. 2 pointers. Longest or shortest contiguous run. Sliding window. Seen it before or a frequency count. Hash map. Cycle or middle of a list. Fast and slow pointers. Overlapping ranges. Merge intervals. Monotonic search space, or minimize the max. Binary search. Shortest path or level order. BFS. All subsets, permutations, or combinations. DFS and backtracking. Do this before that dependencies. Topological sort. Number of ways, or min-max cost. Dynamic programming. K largest or most frequent. Heap. Prefix or word dictionary. Tree. When you do a problem, do not stop at solving it. Ask which pattern it was and which words in the prompt gave it away. That habit, signal to pattern, is the entire skill. Here are all 12 in one frame, your map of the blind 75. 2 pointers for sorted arrays and pairs. Sliding window for contiguous runs with a constraint. Hash map for constant time lookups. Fast and slow pointers for cycles and middles. Merge intervals for overlapping ranges. Binary search for monotonic search spaces. BFS for shortest paths and levels. DFS and backtracking for all paths, subsets, and permutations. Topological sort for dependencies. Dynamic programming for overlapping subproblems and min-max cost. Heap for top K. And tree for prefixes and word dictionaries. 12 patterns. That is the whole toolkit. Every problem on that list is one of these wearing a disguise. So stop grinding for volume. Pick a pattern, do 5 or 6 problems inside it back to back until the signal is automatic, then move to the next. You will cover the blind 75 faster and, more importantly, you will actually be ready for the problem you have never seen. I put the full written breakdown, all 12 patterns with the signals and every example problem, at the link below. And if you want the complete interview prep system, with data structures drills and a study plan, the coding interview and DSA prep bundle is linked in the description. $24, completely optional. Subscribe for more honest developer breakdowns, and I will see you in the next one.